The effects of flooding. So certainly the water moving through a system is going to potentially cause damage to structures and people. So when you have fast moving water, it can impact homes, move cars, damage structures, buildings, roadways, and so there's a lot of potential impact when you have large amounts of water moving through an area. The high velocity means that they can move some really big things. And some of the things that we don't think about are these really huge erosion rates. And so because the water is moving fast, has a lot of energy, it can remove a lot of material. So if your house is supported, built on some material that's relatively loose, it can undermine the foundations of structures, causing them to fail. Certainly bridges, same way. When you build bridges and anchor them to the earth, depending on what they're anchored to, lots of water moving through a stream can undermine the abutments and cause them to fail. And so it's not just the impact of the water, but potentially the removing of the material that the building or structure is attached to. And of course, if you're caught out into the water, you can drown from, not being able to get out of the water quick enough or objects striking you. So um, the power and weight of the water is certainly something to consider. Whether it's a flash flood or a regional flood, both have the potential to do this kind of damage. Certainly the flash flood, more local and potentially might be a little faster when it's moving, so it might impact some cars and things like that. But they're both having these effects here. And of course, there's always some secondary stuff that we see. The water's causing contamination and introducing lots of chemicals and things into water supplies. And so there's pollution hazards. And then you run into, not being able to leave your home or getting access to certain things, destructions of homes and homelessness and things like that. So a lot of things that are similar to other hazards that we looked at. So some of the things that determine how bad a hazard might be of a flood can be related to kind of these items here. So how are we using the floodplain? So when we talk about these big regional floods, is there hundreds of people built homes on a floodplain? That could have an impact on whether those people are impacted. Or is it a couple farms? Or is there nothing built there because it was established that it floods too often? Certainly, the floodwaters themselves, how much water, right? Depth, velocity, how fast it shows up, right? Is it coming quickly? So flash floods versus regional floods. What time do you have to kind of adapt and recover from this? Seasonal, certainly we have more rain in certain seasons than others. Type of material that's being moved, right? Sediment. A lot of times after a big event, the water damage is severe, but it leaves behind all of that sediment that it's bringing with it. And so that gets deposited in your home or structure, and that can be a hazard. And then, of course, how well do we plan? Are we prepared? Can we forecast well? Do we know a storm is coming? Can we get that out to people and let them know there's a flash flood warning or there's a regional flood? And do we have a plan in place to get people out of harm's way? Right. So that's kind of typical of all of our hazards we talk about. Um, and so let's see. So what we can do to that is what we see a lot of times is we're making some of these issues worse because we're altering the landscape, and the landscape certainly has some impact on how the water is moving. And so there's a balance kind of there between, amount of water that hits the ground and gets absorbed and the amount of water that flows along the surface. And so as we kind of change some things, you can see in this case, if we went from a forest with lots of trees and roots, they're absorbing lots of water. And a lot of that water doesn't get onto the ground flow and get into my stream. But if I cut all that down, now potentially I'm seeing more water into my stream. Or if what we see in a lot of cases is urbanization. And so as we then take that nice ground that might be able to absorb some water and pave over it, what we see is bigger and more frequent floods because the water hits the ground. It can't get into the ground, so all of it flows into my stream. And so if we were to use an example of a hydrograph, you can see that without the concrete the storm isn't as big and it takes a little longer for all the water to get into the stream because some of it is lost to the ground. It is soaking in. But without that, all of the water that hits the ground gets in my stream. So it gets there faster and there's more of it. And so we want to take this into consideration when we're building, that we know if we're modifying streams or channels or places where water needs to move through. Sometimes we can construct canals and things to redirect the water, but it definitely has to be something we have to plan for because urbanization is definitely changing some of the flooding hazards that we see. And so this is just an example, right, of the previous one where we see a difference in how fast the water gets to somewhere, right, over time, and how much of it. So how do we control some of these things, right? What's the mitigation thing? So dams are certainly used for that purpose. We use them to control flooding, right? We hold back some of the water that gets into the system. We pool it in a reservoir and we let it out at a regular rate so that we don't have issues with that. And so we can control that, and that's definitely useful. Levees we talked about, we use those for these big river systems, knowing that potentially there's going to be an increase in the amount of water moving through my stream that it might not be able to hold. So I'm going to make the edges higher so it can hold more water and protect the people that live on the edges of my river system. And so here's some examples, of course, of dams or levees. Some are just earthen levees. Some can be structures like this wall here, things like that, or just causing or making canals, places for water to go, redirecting it, taking it away from society or places that people exist so that we can minimize the impact on things like that. And then, of course, our favorite thing we can do too is we can make flood maps, right? So, how do we tell people there's a flood coming? Well, we can map areas. And of course, we do in a lot of issues where the low-lying areas, right? We can use topography to dictate where flooding would occur. And so we look at historical data and say, what's this river done in the past? What places were affected by that? And a lot of times, like I said, it's based on topography. So we can look at topo maps and outline areas that would potentially be affected by different types of floods. How big was that flood? Was it 100,000 CFS? Okay, well, then it's going to flood up to here. Oh, it's 200,000. Well, that's going to flood way up to here. But how often do those things happen? Oh, 100,000, CFS flood happens every 25 years. But a 200,000, that only happens every 100 years. And so we can take that consideration when we're determining where we allow people to build. And so we want to use all of these things to help us kind of predict, prepare, right, and help people kind of not be impacted so much by flooding. So we're looking at all that data, we're looking at mapping data, we're monitoring past behavior, right? We're looking at those probabilities we talked about. We're actually doing those calculations, those recurrence intervals to figure out what's happening. And then we regulate, of course. And so we make maps. So we make flood maps to say these areas are prone to flooding and we maybe restrict some building there. We encourage people not to build in certain places. We educate, like we do. What do you do during a flood? Where do you go? Right. We also require certain people to have flood insurance, and so sometimes it's a way to discourage people from building in a certain area because we say, hey, it's going to cost you a lot more to live here, and that might discourage some people, and we can reduce the amount of people in an affected area. That's potentially possible. Or we could also say you can live here, but you have to build in a certain way. It can resist that 20-year flood or that 100-year flood. Or I might say you can't live here at all based on some of the things that might occur there because it's so prone to flooding. And so some other approaches to kind of keep people out of areas is we develop zones, say this is a floodplain, you have to build a certain way. Or we say, look, this place floods too much, we're going to buy you out and make you go away. Or we limit who can buy or how they can buy based on some mortgage limitations, right? So all of these are regulations, ways for us to discourage people from being in places that are hazardous, in this case, of course, a flood hazard. And so it might look something like this, where we have our cities near a river that's moving through the city. And of course, in some areas, the 20-year flood zone, we would argue you could not build there at all. And that might be a green belt or used as parks or things like that, but no construction there, where if it floods, people would be injured or structures would be damaged. But in the 100-year flood area, it might allow you to build there, but you would have to build to certain levels, right? Certain codes that would be required so that if it did flood, your structure would survive, the people would survive, right? So we're using all this data, we're collecting, observing, doing all these things to kind of manage these different flood events. And so whether they're natural, heavy rainfall comes in, and in an area where it's broad and flat, we have regional floods, or heavy rain comes in where it's steep and we have these really high, huge flash floods, right? We're still trying to mitigate these issues and trying to reduce the impact on people. And there's a variety of ways we can do that. And then, of course, lastly, there's the human-induced kind of flooding that we might see. And a lot of that's from structural failures, levee failures, dams, or overbuilding in an area where we said urbanization is a problem. So I want to look to all of those to kind of help reduce some of the impact that flooding would have on society. So hopefully these videos were kind of helpful for you to go through and look at the PowerPoint. Of course, you're welcome to just look at the PowerPoint and not view these, but I assume if you've gotten this far, you've been watching the video. So hopefully that was helpful.